Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. This is Lesson 5, the area of polygons through composition and decomposition. Putting things together, taking things apart. So that's what we're going to be doing here. Finding area by taking pieces of objects and finding the areas of those particular objects. Okay, so classwork opening exercise says here is an aerial view of a woodlot. Those who don't know what a woodlot is, that would be a wooded area where there are trees growing. So in other words, some woods. So if AB equals 10, so I'm going to label my diagram. AB equals 10, that means from this point here, A, to this point here, B, is a line segment called AB, and that whole thing is a length of 10. Now they're just using units here, so I'm just going to put numbers here and not put the unit down. FE equals 8. So now if I come over here to FE, this piece here is 8. I'm just going to label all the givens. AF, which is right here, is 6. And DE is right here. That is 7. Okay. So those are all the pieces that they give us. We don't know the length of BC. We don't know the length of DC. And that is what they're asking. So here's how we do this. I am going to move my sides now. This number 10, remember, is going to go over here. So if we thought of this as one large rectangle, then AB would be equal to whatever number this would be over to C. So this whole distance here is 10. But then when I move this piece down, that is 8. So DC plus this FE has to equal 10. So therefore, DC has to be 2. 8 plus 2 is a total of 10. We're going to do the same thing on this side here. If I move this straight across, then the distance from B to this side extended over to here. So actually I could also do this. I could put a dotted line here. So there's my rectangle here. So AF is equal to B in whatever this point is here. And then if I take ED and slide it over to here, this piece is 6, this piece is 7, and it equals the total. And so therefore the total is 6 plus 7, or 13. So BC is 13 units, and now I'm going to pay attention to my unit of measurement, and DC is 2 units. Okay, so that's how you do a problem like that. Now it says if DC equals 10, okay, so now they want us to change the values and do it again. So I'm going to erase everything. Okay, now they're saying DC equals 10. So this is 10. FE equals 30. AF equals 28. And BC equals 54. So now they're giving us different pieces. So there's different ways we can represent, there's different ways we can be given values. So now it's asking how long AB is. So in order to find AB, well, it's the sum of FE plus DC. That is the total distance. The green plus the red makes this whole thing. So FE plus DC is going to be the equivalent of AB, and that is 30 plus 10, which is 40 units. Okay, and now we're looking for DE. DE is right here. Now keep in mind that if I move this over to here, that whole distance is 54. This whole distance here is 28. So in order to find out what this piece is here, it's 28 plus something equals 54, or the total 54 minus 28 is going to equal ED. So if I subtract or borrow from here, 14 minus 8 is 6, 4 minus 2 is 2. Therefore, this piece has to be 26. So therefore, this is 26 units. Okay, so that is what they mean by composition and decomposition of. Okay, so now we have this shape here, and they're just calling this a discussion. Okay, so I'm going to look at this whole thing, and I'm going to try to figure out what different pieces are. We don't know the length of this, we don't know the length of this, and this is not labeled. So if I draw a line from here to here that I know is 7 meters, and then I move that up to here, that is also 7 meters. Nothing has changed. Now when I focus on this given here, which is 2 meters, and this piece here, which is also 2 meters, and I move those down to here, okay? So if this is 2, and this is 2, 2 plus 2 is 4, and then I have to ask myself 7, it is 4 plus what, or 2 plus what plus 2 equals 7. So if I called that x, so we start bringing in variables, I could say 2 meters plus x plus 2 meters equals 7 meters. So now I'm going to, instead of just doing it arithmetically like I did up here, I'm going to do it algebraically down here. I'm going to combine like terms on the left, and 2 meters plus 2 meters is 4 meters, plus x equals 7 meters. I'm going to get x by itself by subtracting 4 meters from both sides. And when I do that, these cancel, and I get x equals 7 minus 4, which is 3 meters. So this here, it is 3 meters. Okay, 2 plus 3 plus 2 is 7. Yes, if that was a basic concept, doing algebraically makes it more complex, but we have to get in the habit of being able to do that. So now let me move these out of the way. And I am now going to label this side as 4 meters. And I know this piece is 9 meters. But before I get to that, let me go back to this one. If I slide this over here, we see that it's the same length. So this piece is 4 meters. Okay, so move this back here. And I should be labeling these as I go. This was 3 meters. And this is 4 meters because it's equal to this side. Okay, so now if I move this, and I know this is also 9. Okay, because that is the same length as over here. So this is 9 meters, 2 meters, 4 meters, 3 meters, 4 meters, 2 meters, 9 meters, and 7 meters. Now once we find all those sides, we could actually break this up, find the area of this rectangle, which is 4 times 2, which is 8 meters squared. This would also be 8 meters squared. And the only thing we can't do is find out what this piece is. Because if this whole thing is 9, oh, this is 4. So I could find it. If this piece here is 4 down to here and the total's 9, this would be 5. So this area is 35 meters squared. So I'm taking this one step further, explaining what we can calculate once we know all the sides. We could also do perimeter. 7 plus 9 plus 2 plus 4 plus 3 plus 4 plus 2 plus 9. Okay, so just given a few values or distances, the lengths of certain pieces, we can figure out what the rest of them are and find perimeter and area. Okay, so here's example 1, decomposing polygons into rectangles. The intermediate school is producing a play that needs a special stage build. A diagram of the stage is shown below, not to scale. On the first diagram, divide the stage into 3 rectangles using 2 horizontal lines. Find the dimensions of these rectangles and calculate the areas of each. Then find the total area of the stage. So what I was just discussing in the last page is going to be done here. So A is on the first diagram. So this is diagram A right here. And it wants us to construct 2 horizontal lines to form 3 rectangles. So what they're saying is to draw a line here and draw a line here. All right? So to find the area of this piece, area equals base times height. Area equals, the base is 2 meters and the height is 4 meters. So the area of this rectangle right here is 8 meters squared. Okay, this is also 4 meters because if I draw a line from here to here and then move it over to here, it is the same length. Actually, let me do that again because I didn't go far enough. If I draw a line from this corner all the way down to that corner and then move it, it is also 4 meters because this one is 4 meters. So this area is also going to be 8 meters squared. So we found the 2 pieces already. The next thing we need to do is now move this over to here, and remember that was 4 meters. And then we know this side over here's total is 9 meters. So then when I move this over to here, I see that this whole side is 9 meters long, and this piece here is 4 meters, so therefore 9 minus 4 is 5 meters. That is this piece right here. So this area is base times height, which is, the base is 7, times the height of 5. And put meters as well. So therefore the area of this is 35 meters squared. So now when I want to find the total area, and I'm going to do a little subscript of t, the area of the total equals all 3 pieces, 8 meters squared plus 8 meters squared plus 35 meters squared. So the total area equals 8 plus 8 is 16 plus 35 is 51 meters squared. Okay, so there's A. B says, on the second diagram, divide the stage into 3 rectangles using 2 vertical lines. Find the dimensions of these rectangles and calculate the area of each, then find the total area of the stage. So let me just erase some of this here. I will leave my total down there because we're going to compare. I'll get rid of all of this here, just avoid confusion. And keep in mind that the area of this whole thing came out to be 51 meters squared, and I will leave this down here. So now it's asking us to construct 2 vertical lines. Okay, so well, that would mean to extend this and extend this. Okay, so I know that this whole distance is 9 meters, and I know that this distance is 4 meters. And then if I move this over to here, that's 4. And if I move this over here, that means the total distance, I forgot to write my 9. So if this whole thing is 9 meters and this piece is 4, 9 minus 4 will give me the other piece. So this is 5 meters. Okay, so I'm just labeling everything that we were given. I'll put this back over here. And now we have a rectangle here, but in all actuality, when we did this, we did not need to know the length of this piece. All we needed to know was that if this is 9, then this is also 9. Let me color code it so they match. So this is 9 meters. So I have a rectangle here, which is 9 meters in length by 2. So the area equals base times height. The area equals my base times my height. So the area of these long rectangles that are right here are 2 times 9 meters, or 18 meters squared. So that is the area of this and the area of that. So those are both 18 square meters. Now all I need to do is calculate the area of this rectangle here, and by figuring out that 9 minus 4 is this piece, that's 5, I now have a rectangle here that has a base of 7. This is my base, and a height of 5. So area equals, let me just move this out of the way. Now I'm going to do the calculation. So area equals base times height. Area equals my base of 7 meters times my height, which is 5 meters. So the area is 35 meters squared. Now let me put this back. That was this rectangle here. Okay, so I found these two rectangles to be 18 meters squared each, and this piece here is 35 meters squared. So now I'm going to do my calculation at the end. Use black. Area total equals 18 meters squared plus 18 meters squared. Okay, so the area of this rectangle here is 35 meters squared. So the total is the area, 3 areas total. So 18 plus 18 is 36, plus 35, 36 and 35 is 71 meters squared. Okay, one thing I need to fix here. This whole side is 7 meters. So let me go back and fix this here. This whole side is 7 meters. This is 2 meters, and this is 2 meters. If I move this down here and move this down here, then the length of this piece that I need is 7 minus 2, which is 5 minus 2 more, which is 3. So this piece is 3 meters. So I need to change this 7 to a 3, and I get 15 meters squared. So now when I do my area totals, I get 18 meters squared from this rectangle here, 18 meters squared for the second rectangle, and 15 meters squared for the red rectangle. 18 plus 18 is 36, and 15 is 51 meters squared. So these are equivalent. Okay. Once I saw they weren't equal, I knew there was an issue, so I went back and I found my problem. All right, so my apologies there, and let's move on to C. And it says, on the third diagram, divide the stage into 3 rectangles using 1 horizontal line and 1 vertical line. Oh, okay, that's interesting. So they want us to use 1 horizontal line, so I'll put a horizontal line there. And they said 1 vertical line, which would be here. I'll try to draw that straight. So there's my horizontal line and my vertical line. So I have now created a rectangle here, a really long rectangle here, and a shorter rectangle here. So if this is 4 meters, and I move it over here, I now know that this is 2 and this is 4, and that is my base and my height. So I am going to calculate the area of this rectangle, which equals base times height. Always write the formula first. Substitute in the givens. 2 meters times 2 meters times 4 meters. So the area of this small rectangle here is 8 meters squared. That is 8 meters squared. Now I'll switch to blue, and I'm doing this rectangle right here. So I know my base is 2, so I'm going to write area equals base times height. Area equals 2 meters, which is my base. And then if I look at this and call that 9 meters, and then I move it over to this side, it is also 9 meters. So that is my height. So 9 meters is going to be the height of this. So it's 2 times 9. So the area of the blue rectangle is 18 meters squared. And actually we did it right here. It's the same rectangle. Okay, so now I have this area of 8 meters squared. I have this area of 18 meters squared, and now I need to find the area of this rectangle. So this whole thing is 7. So I'm going to draw this line here and put a 7M, and then I'm going to move it. I'm going to move it up to here. So that whole distance is 7, but I need to get rid of this piece. So that piece is this 2 meters here. So when I move this down, you'll see that I'm taking away 2 meters from this distance of 7. So my side here is going to be 5 meters. This is 5 meters. 5 plus 2 is a total 7. Okay, now I know this whole side is 9. And if I move this 4 that I labeled on this one over to this side, and I know the whole thing is 9, I have now come to the realization that if all of this is 9 and this piece is 4, this piece has to be 5 as well. 5 plus 4 is 9, and over here, 5 plus this 2 is a total of 7. So now I have a rectangle that's 5 by 5. So the area of this piece, let me change colors. So I've used red here. The area of this piece is base times height. The area equals the base, which was 5 meters, times the height, which is 5 meters. And I have a squared here, so let me move this and get rid of that squared symbol. That's not it's a distance, not a length or an area. That's 5 meters, not 5 meters squared. Okay, and then I need to calculate this, and 5 times 5 is 25 meters squared. So now I'm going to calculate the sum. The area total will be the 3 triangles, which is 8 meters squared plus 18 meters squared plus 25 meters squared. So the total area is 8 plus 18, which is 26, plus 25 is 51 meters squared, which is equivalent to both of these. So no matter how you slice it, you still have the same piece of pie. Okay, so now here's a diagram, and it says think of this as a large rectangle with a piece removed. What are the dimensions of the large rectangle and the small rectangle? So the dimensions of the large rectangle are 7 meters by 9 meters. Those are the dimensions. And we use an X when we say dimensions because this doesn't mean times. It does, but whenever we see this, it means 7 meters by 9 meters. And the small rectangle is right here. And that is 4 meters by, this whole thing is 7 minus these 2 and 2. This is 3 meters. 2, 3, 4, 5, 6, 7. This side equals this side. So the small rectangle is 3 meters by 4 meters. What are the areas of the 2 rectangles? The larger one, the area of the larger equals base times height. The area of the larger equals 7 meters times 9 meters. So therefore the area of the large equals 63 meters squared. Small rectangle, the area of the small rectangle is base times height, which substituting in gives me 3 meters times 4 meters. So therefore the area of the small rectangle is 12 meters squared. Part 3 says what operation is needed to find the area of the original figure. And if we have a big one and we're taking away, we want to take this away from the big rectangle, leaving us with that shape we had before, this cut out, then it's subtraction. What is the difference in area between the two rectangles? So we take the area of the larger minus the area of the smaller, which equals 63 meters squared minus 12 meters squared. 63 minus 12 is 51 meters squared. It says, what do you notice about your answers to A, B, C, and D? So they're talking about the last page. The answer to A was 51 meters squared, the answer to B was 51 meters squared, and C was 51 meters squared, and now that we've done subtraction, the area is also 51 meters squared. The areas are all the same. And the reason that is true is because adding pieces that you're going to combine to make one area is going to be the same as taking a large area and subtracting the piece that was missing. Okay, so now we're going to be decomposing polygons into rectangles and triangles. So we have a parallelogram here, it's called ABCD, and it's part of a large solar power collector. The base measures 6 meters, as labeled here, and the height is 4 meters, labeled here. A says to draw a diagonal from A to C. So there's my diagonal from A to C. Find the area of both triangles. Now we have a triangle ABC, which is this bottom one. This is triangle ABC. So triangle area of the triangle ABC equals base times height divided by 2. The base was 6 meters. The height was 4 meters divided by 2. I'm going to reduce before I multiply to keep the numbers small. 6 divided by 2 is 3, and then I just multiply the 3 meters times 4 meters, which is 12 meters squared. The other triangle is ACD. So if I go from A to C over to D, that is this triangle up here. It's this piece here. So the area of triangle ACD equals the base times the height divided by 2. The base is 6 meters times the height 4 meters divided by 2. Again, we're going to reduce this 6 to 3. And that cancels the 2 as well. And then 3 times 4 is 12 meters squared. So both of these rectangles, or this rectangle broken into 2 triangles, both the triangles are 12 meters squared. B says draw in the other diagonal from B to D. So now it wants us to draw in the diagonal from here down to here. There's BD. Find the area of both triangles ABD and BCD. So ABD is here, so that would mean to get rid of this diagonal and get rid of these triangles. So I'll just move these off to the side. And now we're focusing in on these 2 triangles. Well, the base again is 6, and the height is 4. Nothing has changed. So the formula is going to be identical to this, except for the names. So I'm going to just skip this part. They're just trying to solidify that no matter how you slice this parallelogram, you're going to get, the area will never change. I'm going to move on to the next example, and it is a trapezoid. We're going to decompose the trapezoid. The trapezoid below is a scale drawing of a garden plot. This is called base 1, and I'm going to label it base 1, and DC is base 2. 5M is my height. So those are the 3 things they gave us. 2 bases and a height. It says find the area of both triangles ABC and ACD. So what they're telling us to do is draw a diagonal from A to C. And now I have this triangle here. Okay. So the area of triangle ABC equals base times height divided by 2. The base of ABC is 8 meters. The height of ABC is 5 meters divided by 2. 5 times 8 is 40 meters squared divided by 2. So the area of triangle ABC is 20 meters squared. Now we have triangle ACD. The area of triangle ACD equals base times height divided by 2. Now the base of this triangle is 4 meters, and the height, which would be this as well, which is 5. The height has not changed. Actually, if I want to show you it this way. So if this is my height of 5 right here, and I slide it over here and draw this over here, then we would have a height of 5 meters for this one as well. So that's 5 meters divided by 2. Now I'm going to do this one differently. I'm going to reduce first to make that a 2. And now it's just 2 meters times 5 meters, which is 10 meters squared. It says find the area of both triangles ABD and BCD. Now it's saying ABB, so what they're saying now is to get rid of this line. Oh, I can't delete it. I'd have to delete it. Let's do that. Okay, and now I need to draw a diagonal from here over to here. And now it says find the areas of both A, B, D. Well, that is going to be a base of 8 and a height of 5, so it's equivalent to these up here. And so we're going to get 20 meters plus 10 meters, and it says find the area of the trapezoid. I hadn't finished the last problem, so let's go back to there. Okay, and the area of the trapezoid equals 20 meters squared plus 10 meters squared. So therefore the area of this trapezoid equals 30 meters squared. This is going to be the same. I'm not going to do that again. I will do that in class, but I'm not going to take time on the video. And it says, how else could we find the area? Well, if I get rid of this, erase this all. Okay, another way I could have broken this up is this as a vertical line that formed a perpendicular and a height. I could do the same exact thing here. Okay, this is to answer this right down here. So now I have 2 triangles and a rectangle. So I could take the area of this piece plus the area of this rectangle plus the area of this triangle. Well, this whole thing is 8 and this piece is 4. Okay, so I know that this distance is 4. So this is 4 times 5 meters squared, or 20 meters squared for my rectangle. And then I could find this triangle here. The problem with this, though, is that I have a distance here that I don't know, and I have a distance here that I don't know, and there's 2 unknowns. I could call this 1 meter and call this 4, 5, this would be 3 meters. So what I'm saying is this 4 meter piece here plus this 3 and this 1 would have to add up to 8. Or I could call that, would 2 and 2 look right? No. So I'd probably assume this to be 1 and this 3. This could be 1/2 and this could be 3 1/2, as long as 4 plus this adds up to a total of 8. And that was one other way we could do it. Okay, that is the end of lesson 5. Go do your problem set.